So now what is the force going to be here? So we have 182.87 minus 0.4 n minus n prime is this one, is equal to 8a. This equation tells us n prime is equal to 3a. N prime is equal to 3a. We can substitute that n prime over here. So 182.87 minus 0.4, n is equal to 107.8 minus 3a is equal to 8a. See that? So I have a little stronger force. This factor stayed the same, and I have 3a here is equal to 8a. So what does that come out now? (182.87 minus 0.4 times 107.8 is equal to 11a. So 182.87 minus 0.4 times 107.8, okay, divided by 11. The acceleration is now 12.70. Before, the acceleration was 12.25. So now the system is accelerating forward quicker, which makes sense. Okay, and then what's n prime? N prime is equal to 3 times a, okay, which is 38.11 newtons. So there's 38.11 newtons pushing that. Now let's check one quick thing. Look, what's the maximum that friction can be? What's the maximum? The maximum is mu Sn. Fs prime maximum. Mu S prime n prime. Fs prime maximum. Mu S prime was 0.8, right? You multiply that by the n prime, which is 38.11. In other words, friction can equal maximum of that value when you're pushing with that force. So you have 30.49. It can equal 30.49. It only needs to equal 29.4. So is there sufficient friction in order to keep that from moving down, from falling down? Yes, there is, because it can equal a bigger number than what it needs to equal. So since this is greater than this, that means if you push with a force greater than that, it will stay where it is, okay? If you push with a force less than that, what's going to happen? Then it's going to start sliding down. There is not enough friction force provided there, okay? So let's say this question, let's say part C. What if F equals F min minus 5? What if you push with a force 5 newtons less than what was necessary? Then what's that going to be? 172.87. Now what's going to happen? The 3 kilogram block should slide down, right? So now you're going to have 3 kilogram, you're going to have 29.4, and you have n prime, and then you have here mu k prime n prime, and mu k prime was 0.6 n prime. So the 3 kilogram block is sliding down. Okay, so I have 29.4 minus 0.6 n prime equals 3a, sliding down the in front of the 8 kilogram block. We can call this A prime. It's the downward acceleration, right? So this is the downward weight, this is the upward force of friction, and then this is the the horizontal direction, we have n prime is equal to 3a. Okay? Then you have the forces on the 8 kilogram block. So you have 172.87. You have 0.4 n. You have n. You have 8 times 9.8, which is 78.4. Then you have n prime. And then you have the opposite of this, right? Again, 0.6 n prime. 0.6 n prime pushing down. So the forces there are 172.87 minus 0.4 n minus n prime is equal to 8a, and then n is equal to 78.4 plus 0.6 n prime. So there's like a cycle going on here. N depends on n prime. Okay, and then n prime determines the a. So let's put this all together here. N is equal to 78.4 plus 0.6. N prime is equal to 3a, right? Right, so then n is equal to 78.4 plus 0.6 times 3, that would be 1.8a. So that's my n, which I can substitute here. So 172.87 minus 0.4 times n, which is going to be 78.4 plus 1.8a, minus n prime is equal to 3a, is equal to 8a. So you see you have the 0.4, and then you have the n, and then you have the n prime, then you have the 8a. So now distribute the 0.4 in, okay? It's a pretty good problem here. So what ends up happening here? 0.4 times 78.4, 31.36, this one. Okay, so you have 172.87 minus 31.36. 0.4 times 1.8, 0.72, that's negative 0.72. And then that's a. Negative 3a is equal to 8a. So the 3a goes over there, and the 0.72a goes over there. So actually we can solve for a from here. 172.87 minus 31.36, 141.51, and then over here we're going to have 11.72a. So 141.51 divided by 11.72, a is going to equal 12.07 meters per second squared. So notice the acceleration is now less than what it was that you needed in order to keep it stationary. So it's accelerating slower. So if that's the case, we can now put it into here and solve for n prime. N prime is equal to 3 times 12.07, 36.22, because I'm using a non-rounded version here. N prime equals 36.22. We could also solve for n if we wanted to get the answer. Then we could take that, put it into here, and calculate the downward acceleration of the 3 kilogram block. So you have 29.4 minus 0.6 times 36.22 is equal to 3a prime. You see? Because the 3 kilogram block is accelerating down. So 29.4 minus 0.6 times the answer. This thing comes out 7.66. Divide that by 3. The acceleration comes out 2.555 meters per second squared. So that's pretty quick. So if you exert a force 5 newtons less than what's necessary, the thing is accelerating down at the rate of 2.555 meters per second squared, and it's accelerating forward until it finally hits the ground. Very, very interesting problem. A lot of good physics there. Very good illustration of a complex problem involving lots of different stuff, but it's definitely solvable if you break it down into its pieces.